Hello, my name is Edgar Pedraza, and in this video I'll be covering how to check LDTs with the FabTech kit. We will be using a horizontal and a male and female vertical with relative and absolute machining, and we'll be checking both in this video. So for the relative machining, we will be checking whether or not we have the correct X position or Y position, while with the absolute machining, we will be checking the model and job and even opening up that LDT in CamPlus and seeing if whether or not it's the correct LDT. So let's go and just get started. We'll begin with checking the horizontal, and here we have a formula to help calculate the X position and Y position on any given horizontal. So please pause the video, jot this formula down so you can do the example along with me. Also, please note, for reference, please watch these two videos, how to edit, review, and enter data in the die info table, and how to review and edit the machine locations from edit whole locations table. These two videos will help you and go more in depth on how to achieve some of the information that we need for this step. So we're going to go ahead and start off by either opening up the PDF for the part that we're working on or the CAD file. As you can see here, I have the CAD file for this W75-3175 on Band's Headquarters Week 1. And we're going to be specifically looking at this HM2-2H mark number. So the preference of working off of the CAD file is we can go ahead and type TM, and we can see all the notches that were made on this part already. So we can see we have a notch on the left here, we have a notch on the bayonet, and then the same notches on the right as well for as this layout for these holes. So if we go back to paper space, what we're going to go ahead and do is open up the USF in the job program. As you can see, I already have it open, and you can see all the different mark numbers associated to this part. But like I said before, we're going to work on this HM2-2H, and I already have that open here on the right. So we can see all the LDTs already on here, and we have the relative that always populates first, and then the absolute at the bottom. So we're going to go ahead and check the absolutes first. So theoretically, you can have the job program open up on one side and AutoCAD on your other screen, and just at a glance look at the machining and compare the two. Or you can also open it up in CamPlus if you want to take a better look at one of the machining. So say we want to take a look at this LDT. I'm going to go ahead and click that CamPlus here, and then I'll open it up, and then I can go ahead and double check whatever I'd want to look at in here, whether it's at the correct X reference or whether the blade's set at the correct location, anything like that. So I'm going to go ahead and minimize that. So that's how we would check the absolute machining. But for the relative, we would need to check the X position and the Y position. So if I rotate the model here, we can see those holes are at the bottom of the part. And to get those X position and Y position, what we would do is we go back to either the PDF or the CAD file, and we would locate the starting position. So the location is set up here at the table. So for this LDT on these holes, we're going to reference this tube notch 5 under the part number, and then the location is set to 22 inches and an eighth, and that's to the datum. So from there, we're going to go ahead and add 13/16. So if we do 22 inches and an eighth plus 13/16, that gives us 22 inches and 15/16. So we're going to go ahead and double check that here. So for the X position on these two, that's correct. And then we're going to go ahead and check the X position on these other two. So if we go back to the fab, so what we're going to do is now work our way to the left. So we're going to subtract the 13/16 that we added, and then we're going to go ahead and subtract 3 and 5/16 from that 22 and an eighth. And that gives us 18 and 13/16. So let's go and check that. And there we go, that's perfect. So we checked the X position, now we need to check the Y position. So in order to do that, we need to know the VDIM1 of the part. So the VDIM1 is from the back of system to the glass pocket here. And in order to get that, we can either go into the die info on the, and we can find that here, or we can just simply go into the CAD file and dimension that out. So we know that's 5.25, and then we have dimensions here to the center of the hole. So we're going to go ahead and subtract 1 inch and 3/4. And that gives us 3.5. So there we have it, 3.5 for these two. And then we're going to go ahead and subtract 1.5 inches to get to the other hole. So it's going to be 2 inches. And there we have it, 2 inches. So we went ahead and checked all these. So these all look good. And then we're going to go ahead and move on to the vertical and learn how to check those LDTs on that part.
So we'll move on to check the male vertical, and here we have a formula to help calculate the X position and Y position for the male vertical. And once again, if you'd like to follow along, please pause the video and jot the formula down so you can do the example alongside me.
So we're going to go ahead and check the verticals now. So we're going to start off with this W755262. It's going to be a male vert on Van's headquarters week 1. And the mark number we're going to be looking at is this SV2-10. And then just like the horizontal, we're going to go ahead and open the USF for this part and check the absolute machining and the relative as well. So I already have that USF open here and already selected the SV2-10. So we can see all our relative and absolute LDTs here. Just as the horizontal, the relatives populate first and the absolutes are at the bottom. So we have a pretty good look at what the absolute LDTs look like here. But just like the horizontal, if we want to take another look and open up the LDT in CAMPlus, all we would have to do is just select the CAMPlus symbol here, and then it would open it up. But those look correct, so I don't want to do that. I'm just going to go ahead and check the relative X positions and Y positions, and I'm going to go ahead and start off with the sill. So I know the sill are these LDTs here, along with these access holes. So in order to get the X position for these holes, what we're going to do is we're going to take the location of the sill, and then we're going to subtract it by the HDIM2A of that cell too. So let's go ahead and get the location first. So I'm going to go ahead and open the CAD file, and we're going to see this W751156, and the location set to 2 1/16. So we're going to take 2 inches and 1/16, and then I'm going to go to the takeoff program, and I already have the die info table open, and I selected the cell already here, as you can see. So I'm just going to subtract the HDIM2A, the HDIM3A, and the HDIM4A from the location, and that should give me the X position for this LDT, this LDT, and this LDT. So let me go ahead and do that. So I'm going to go 2 1/16 minus 1/4. So that gives us 1.8125 for this hole, and then we're going to have to do 2 to the 16th minus 1.8125 to figure out that one. So 1.8125, that's correct. So if we do the 2 to the 16th minus 1.8125 for the third hole, it gives us a quarter, and that's what we have here. So that's how we calculate the x position. But for the y position, what we would do is we would go ahead and take the v-dim1 of the vertical and then subtract it by the h-dim2 of the horizontal. So let's go ahead and get the v-dim1 of the vertical. So I'm going to go ahead and get the 5262 and then go under v-dim1. So it's 5.25. And then we're going to go back to the cell here, and then we're going to subtract it by the h-dim2. So we have h-dim2 minus, so 5.25 minus an inch, and then we have 4.25 for the first hole there, and here we have this one, and then let's go ahead and do the other two. So 5.25 minus 4.25, so that gives us an inch. And then what's the h-dim4 over here? It's just an inch again. So we have 4.25 and then 1 inch. So there we have it. And then we do the same thing for the horizontal or the head. So if we were to do the head, we would get the location for the head here. So we're going to do 5262 and then get the v-dim1, so 5.25, and then we're going to calculate the y position. So let's see, it's a 3165. So 3165, and then we're going to subtract it by an inch again, and then so it should be 4.25 for one of them, and the other we're going to subtract it 5.25 minus 4.375. 75. So we should get one that's 4.25 and 0.875 for the y position here. So 0.875 and 4.25. Perfect. And then we're going to calculate the x position for those as well. So we're going to go ahead and go back to the fab. We're going to get our location. So our location is 116 inches and 9/16. And then we're going to subtract that by the h-dim2a of the horizontal. So let's go ahead and go back. So the h-dim2a, so it's minus 0.5. So our location should be 116 and a 16th. Perfect. And that's how you calculate the LDTs here. Now we're going to go ahead and look up and check the female vertical.
Lastly, we'll be checking the female vertical, and here we have a formula to help calculate the x position and y position, but note, the only difference in this formula to the male one is the formula for checking the x position.
So we're going to work with this W755263 for Vans headquarters, and then the mark number is SV1-5S. So same as the other parts, we're going to go ahead and look at the absolute machining and the relative and use this CAD file to check the LDTs in the job program. So I already have the USF open here, and I already selected the mark number that we're working with, this SV1-5S. So all these LDTs here, the relative and absolute, are assigned. And as you can see, we only have these two absolutes, but the difference between the female and the male is the female, as you can see, the bottom of vert is here on the right side of the part, rather than on the male, it was on the left. So we had to, that affects the way we calculate the X position. So I'm just going to show you how to calculate the X position on this sill, and everything else should be the same as the male vertical. So let's go ahead and check the absolute. So those are correct. Those are just the bayonet holes at the top of the vertical. So I'm just going to look at the sill holes here now. So it's going to be these three here and then these two axis holes. So in order to calculate that X position, what we have to do is we have to get the cut size of the vertical. So we have to go back to the PDF here, or the CAD file of the PDF. So our cut size is 217 and an eighth. And then what we have to do is we're going to subtract the location of the sill. So we're going to subtract 2 and a 16th from the cut size. So we get 215 and a 16th. And then what we do now is we have to add the HTM2 of the sill. So, or HTM2A of the sill. So 1171, I believe, is the sill. Let me just go ahead and double check. Yep. And then, so what we're going to go ahead and do is open up the diaphragm again. And we have the 1171. So we're going to go ahead and look for the HTM2A. And then we're going to go ahead and add that to the 215 and the 16th. So we're going to add a quarter of an inch, and that gives us 215 and 5/16. So let's see if that's correct. And that gives us the location here for this one and this one here. So now we're just going to have to do the next one. So we're going to subtract the quarter that we added. So we're back to the 215 and the 16th. And then we're going to go ahead and add the 1.813. So let's go ahead and add that. And we get 2/16 and 7/8. So let's see if that's over here. And there it is. Perfect. So that's how you calculate the X position on a female. The Y position and the rest of these are the same as the male. You just need to do the same formula for calculating the X position on the rest of these horizontals. But this has been how to check LDTs with the FAB ticket. Thank you for watching.